Hello and welcome to a new session on the topic ArchiMate for Architecture Modeling in alignment with TOGAF Architecture Development Method ADM. In today's session, we introduce a case study of an IoT home automation system, and let's together model the entire architecture. We'll start with using ArchiMate, new ArchiMate view. We'll start with setting out our motivation. Why are we doing this? This is quite important. We need to address this almost always when we are introducing a new architecture. Why do we need to do this? So that the stakeholders alignment is also addressed. The stakeholders who are attending the architecture review board sessions, they know why we are doing this. This is quite useful in ArchiMate that you have the motivation layer so that everyone knows the reason, the motivation, the strategic goals behind the architecture. I'll give my ArchiMate view a name, case study, smart home. So in this hypothetical scenario or use case, the enterprise, the organization we are working for, they are specialized in uh, electronic devices, and now they are investigating introducing smart home devices and in alignment with the software offering so that they can increase their market share of the IoT trend and smart home. So the stakeholders who are concerned here in this case, management or sales, of course, the production, operations, sales, these share a common interest, a common goal. We want to introduce smart home devices. Of course, you address this on a business level, you address this on a strategy levels. What are the capabilities? As you have seen here previous sessions, we addressed the strategy with resources and the capabilities and value streams, etc. I will keep this focused on the topic of architecturing the smart home device interaction with the cloud offering. So introduce smart home devices, and out of this we have a concrete requirement. So the requirement is to utilize hardware-software interaction to optimize electricity consumption for end users. End users here we say it could be a factory, it could be a production facility, it could be just, as we said, a smart home. We stick with the smart home, and this is a very clear requirement. We want a system based on artificial intelligence, machine learning, analytics, predictive, descriptive. However, we are going to introduce the software components based on the telemetry data from the hardware devices. We are going to give recommendations to the users to optimize their electricity consumption. So this is the main guideline. Of course, you can find always a very better concrete wording. I will stick with this one for the sake of example in this case study. Quite aligned, quite centered. Always using the magic connector makes it quite easy. You can see descriptively which elements you are using. This is the realization of this goal. Of course, we have introduced outcomes, and the outcome should be specific that we in Q1 we have a product tested on the market with 10% market share. So we could say that for the sake of example, we say the outcome we are seeking 10% market share in Q1 and the year this year 2026. And in that case, our goal will shift slightly lower. And again, the relationship from the outcome to the goal is that this outcome is the realization of this goal. So far, so good. We have now our motivation layer elements. So this is our reminder, our alignment with our stakeholders, why we are doing this. We start with the home. The home is a physical element. We start with the facility here. This is a home, consumer home. And of course, we can add more than one home in case we are using connected, decentralized system, vacation home and the residence, etc. We'll start with one for sake of example. And then what are the elements that are associated with the consumer home? We have gadgets, devices. So we have here the device element. We have temperature device, temperature sensor, and we have lighting sensor, light sensor, luminance. So we check the luminance, daylight, and use that to regulate, optimize the usage of the lighting. And these are associated with the facility or assigned to. So this is it's not service, it's not triggers, it's not flows, it's aggregation. They can exist on their own or they are assigned. I like the assigned because it say this device is installed on this facility. Of course, you can argue the arrows in the wrong direction because the sensor is assigned to the home and not the other way around. I'll stick this matter of specification that the assignment should be the other way around. In this case, you could have used just a simple association, but it is allowed by the standards of ArchiMate, so I will keep it. So the facility is assigned to the devices. I will interpret it that the light sensor and the temperature sensors are installed on the facility. We need also a home server. We need an interface that communicates with the sensors and then collect the data, convert it to some format, let's say MQTT protocol conversion to AMQP protocol, and transmit it to a cloud solution. So this is a cloud-based solution. We could have introduced some offline capabilities. For the sake of example, I will keep it as simple as possible. So we have here home server. And the task this home server performs, what task does this perform? Is this a business task? Is this a business an application service? We can argue. I will use an application because this is an application. MQTT AMQP converter. You can be more abstract and say this is just an application to Home Hub or connector. An IoT gateway would be even a better name. So we can call it IoT smart home gateway. But we know it performs as a hub, or as a buffer, as a cache, offline caching when the connection is not working. It converts the MQTT protocol to the AMQP protocol. So it communicates, it's also assigned to the home, associated with the home, with the consumer home, and it communicates with the data, pulls the information from the sensors, or the sensors push their information to the home server. So this flow, the other way around. So light sensor sends its data to the home server. So far so good. To indicate that this should work online when the connectivity is not quite efficient, I would say there is a storage element. Could be another device, storage, local storage. Could be SDD, it could be network attached storage. I'll keep it abstract. So is assignment, composition, aggregation. So the other way around. So we can aggregation. So the home server aggregates the local storage. The local server now is attached to aggregates local storage as well. We can even be more explicit about the functionality of the home server. So we could add some business function that it performs. We could say offline capabilities, offline durability, or the business service is that it's available offline. This could be a business service. It could be also data privacy reasons. They want the system to be available also offline without online connectivity. This could also be associated with the home server. I would say the business function, from a business perspective, what value does this hardware together introduce from the perspective of the business stakeholders, so that they can later, our sales team can proposition and sell this value to the customers. Ensure local durability or local operations. Better namings, leave it to the marketing team. Of course, the wordings and vocabulary and namings, industry specifics, they become very concrete and elaborated throughout the discussions you conduct with the stakeholders. You could even have that in the architecture work package. But this is here a business goal. And this business goal is realized through the home server. Now the graph needs to be restructured. So I try to keep the visual arrangement of the image, that motivation layer at the very top. Business follows, then application, and then hardware. So this is one way to do it. I will see if I need to do that more often, then I will associate that in the specific layer, but I will, for the sake of simplicity, I will arrange it here just to the side of the home server, and we understand together that the business comes first, or in between the motivation and the application and the info. And then the smart home gateway, this is the name of the application that will run on the system. So no assignment again between the service and the device. So we'll pick the annotation that's as close as possible. So is it a service? Is the server serving the application? Triggering or flows? The closest I find here is association. So we have now the facility side. We have a grouping visual element now to it. Send back. And add the composition to this group. And this is our edge. So far so good. We have an edge. We need a cloud. One of the concepts that you'll hear often is that it's edge and the cloud, and there is in between the edge and the cloud, there could be also a fog layer. Fog layer, that's an intermediate layer. It could be a WAN, wide area network. It could be on-premise. It could be a facility of facilities. So this is one of the terminology in the world of IT: edge, fog, and cloud. So in our cloud structure, we will focus more on the application layer, assuming that we have all our compute, storage, GPUs, etc. So it's a matter now of layering the application service. We have some security components, so we say a web application firewall or firewall because I want to emphasize security in my design. So there is a firewall, and there is an application gateway. Before I come to that, I will want the firewall to be a technology service, because this is a infrastructure related service. So it is a firewall, VPN, connectivity, so communicating over private or public internet. This is all different possibilities. Say here we have a network, communication network, and this communication network, VPN, private link, it's not communicating over public internet. And then the bus. We could have the bus here, the connectivity itself, private connection, and then the network is a VPN virtual private network. One way to model it. Be many other ways. And this is the flow. Service triggers, flows. You can use it here, flow from smart home gateway to the over the private connection, and flows over to firewall. So it's quite tricky, even if I'm myself a certified ArchiMate practitioner. According to the ArchiMate 3 specification, I always find it quite tricky to get correct connections. There is no way you can memorize that by heart. With practice, it comes, you get a sense of it. Also, there is a matter of flexibility that you interpret it as you are giving this to another stakeholder, or you explain it in a session or a workshop. On the other hand, if you give it to another architect who is as ArchiMate certified practitioner as well, perhaps he will have another opinion, another convenience that he has been using over the years, and they find it's also quite counterintuitive that you are using these annotations in your own way. These are all matters of experience and alignment and standards used in the organization. For inspiration, you can check some of the ArchiMate modeling architectures in your organization to see how they are modeling different connections and see if they have developed a standard over the year, a standard of how to use the standard. That's what I mean, or a guideline. Again, the TOGAF and the ArchiMate, they are specifications and standards, and they are also offering flexibility to adapt them to your own organization and enterprise architecture needs. We stick here and we are conform because all of the connections here, they are allowed connections. That means that if we try to do a connection that is not allowed, so let's say, for example, influence relation is quite generic. Let's say assignment. Let's say the assignment relation here is not allowed. You see, so this kind of blocking of the usage against the standard, this makes sure that what you are using is standard conform, and adding some sense of intuition of interpretation to it is one other way. Another way to highlight here also is that you can also revisit the documentation. Always have the documentation at hand. This is available from the ArchiMate for specification pocket guide from the open group, downloaded from the website, and then you are good to go. That being said, let's continue. So here we have our edge, smart home gateway, private connection, firewall. The VPN is the realization of the private connection, or is assigned to the private connection. And then comes our next part, which is the application layer. And here on the application service, we have an interface, an API. So this will be the first point where our data, telemetry data, hits the system. So the pre-processing service, quite generic name. This will validate the data and store them in the database, as simple as that. Telemetry pre-processing service. We have not specified here in this communication over an message broker, asynchronous or synchronous. This is quite important here to be very clear and concrete about it. So I'll even move that a little bit further, and we add an interface, async message client. Is this a message broker client or is this an API? There are arguments for and against using a message broker directly exposed to the cloud. One of the arguments, they say the enforcement of security and structures and changing the schema require the change the schema in the edge, and this means that you need to update your firmware. Other discussion is that the communication with SSL and will be encrypted, etc., with a message broker, but still you are exposing an internal component, internal infrastructure to the outside. Perhaps the topics are not quite isolated as they should be. An API is more appropriate in this case because you can enforce authentication, authorization, RPAC, policies, more rich in comparison to a simple message broker, even though simple doesn't really fit here because message brokers have developed. I would say let's stick to the conform that this async API client. This would be more conform, of course, with application gateway in front of the firewall. You can have web application firewall. You can see the list goes on and on and on. And for authentication and authorization, I will connect to the application gateway authorization auth server authentication authorization policy. You can add our custom policies. So the diagram is getting a little bit now overfilled, get even more complex as we move on. So assignment, the async API is assigned to the telemetry service. The application gateway, the flow relation, not flow relation. And then the auth server is being used by application gateway to validate the request. The person who is trying, the data is coming from the correct source and being addressed to the correct endpoint. There could be some manipulation in between. Someone has hacked one of the devices and tried to address other endpoints using the authentication service. This is one of the possible cyber threats. You know that distributed systems and IoT systems are very vulnerable to cyber attacks. So you need to be very specific, very clear here in your architecture modeling that cybersecurity is one of the main pillars of your architecture. So this is a service relation. So the auth server serves the application gateway. The application gateway uses auth server. And again, flow. Telemetry processing service. We could reduce the size a little bit so that it fits on the screen. We write the data to the database. How we model the database as a system, as a server. Let's use a system here because this is a system software. Database management system. And then you can show that this is a time series database. The OpenTelemetry database can be very specific. And then this is a flows. Let's see the possible connectivity options. Service triggers flows. So the data flows from the processing service to the DPMS. Here we have our very nice cloud connectivity. Trying to make some rearrangements so it looks a little bit slightly better. So, and then we have from the firewall to the DPMS. Now we have covered our cloud. Let's revisit it all. Utilize hardware-software interaction to optimize electricity consumption for end users. In that case, I would say we need an actuator to complete the cycle. There is one path. We are collecting the data, telemetry data, and analyzing them. The second path is that we are delivering the recommendations to the smart home endpoint so that actuators can turn on and off the lighting, switch it up and down. This is another possibility. I will stick to the analytical path and I will say we deliver the recommendations through a mobile application to the end user in the first stage, because remember, this is a goal for 10% market share in Q1. Not sure if we have the resources and capacities to implement this in Q1. This is actually one of the questions that are quite relevant to the enterprise architect role, whether we have the resources and capacities to implement this architecture. If it's too complex, you deliver the target architecture, and in between, in the layer of the ADM method, migration and planning, or planning and migration, you deliver transient architectures, revisit that with alignment with the product owner, the project management, what are the resources and capabilities available, because here you have the tool, the resources, so you can also model that in your process. For the sake of the case study, I will stick to the analytical path. Then we'll have an analytical service, analytics service. The analytics service will access the database management system. Let's see if that is allowed or not allowed, because this is a system, not a topic. Let's use flows in the other way around. So the analytics service uses the data in the database management system and then writes them into the database management again, or another analytics storage operational database. Let's say this is time series telemetry database, time series DB, could be MongoDB, Elasticsearch, OpenSearch, and then deliver it to another database management system, which is operational database, application database. See the flows. And the analytics service, they emphasize that to do the analytics we need AI. So to have AI, we need to emphasize that we need here devices, AI servers, AI GPUs. So to emphasize that this is AI driven analytics, you can have it on the other side. Reduce it a little further. It all fits. See, as you grow with the complexity, as the complexity of the architecture grows, you find that the alignment or rearrangement of the architecture is quite exhaustive. So it is served by the GPUs. So time series DP analytics service uses AI GPUs, deliver the data into the application database. And we have here backend for front end or mobile app service. Accesses the data flows from the application database to the mobile app service. The mobile app service uses the application DB, and then we have events, business events or application events. These are application events, push notifications, and we deliver push notifications to whom? So the mobile app service generates service triggers, flows, associated triggers, events. Mobile app service triggers push notifications, and the push notifications, they are delivered to our customer on his smart phone or smart app. So we need a device. Of course, we could add an icon for mobile applications. We don't have a device in the business layer. Mobile device, smartphone. And this is our customer who can then go and adjust. So the push notifications are delivered to the mobile device. And the customer can access these mobile devices to get the notification. Service triggers flows associated, served by, triggered by. So he accesses the mobile devices to get these notifications. The mobile app service will need an entire architecture because it needs authentication, authorization, how the push notifications are delivered with encryption, and so on and so forth. So we could also go that complex and add the whole entire ecosystem of the mobile device. We could even have an entire abstraction over the architecture. We don't have to be very detailed about our processes and flows and services. It's a subject of the goal itself. Is the goal to show the hardware software interactivity? Is it more about the mobile application? Is it about the cloud architecture? Is it all of them? I would say usually you should have a very high level view of the architecture, but sometimes it's very tempting to ignore some of the boxes, the elements, components that make up your architecture for the sake of simplicity. Of course, in this session, in this example case study, it's not harmful, but in real life, if you show this to a stakeholder and say push notifications flow to the mobile device of the customer, and then you ignore security or encryption, then it means it goes through the implementation layer without any encryption mechanisms. So you need to see these notifications are APN protocol, or depending on Android mechanism for push notification, what are the available security mechanisms. So for the sake of example, I will just add one of the security mechanisms available: push notifications, mobile device. So you need certifications associated to that. This is an application object. Not a data object really, but I'll say this is certifications. Push service certifications and device certifications. Device customer certifications. So this is a security mechanism that's being accessed by the push notification service. This relation is access. So a service accesses a data object. We can assume certifications as also containing data, so they make data objects. Where is the firewall located? Is it located on the edge or in the cloud? In the cloud. The VPN is a matter of connection. The mobile device belongs to the user. Can now realign our system. Add a grouping. And this is our cloud. We can even segment our cloud further to client-facing cloud and back-end or isolated protected area in the cloud. There are so many ways. For the documentation, we should have this relation fixed for the sake of documentation. We have this whole composition with the grouping so that it shows that the cloud is a group when we generate documentation using the Archi system. Align it further. You can even make this slightly, just slightly better. And here we go. Let's fit it on the page. So on the page here, you can see we have covered edge and cloud. You can even go further and add fog architecture. We need to do some alignment with the motivation layer. So how this requirement is related to this entire target architecture. I say target architecture because there could be also transit in between architectures until we reach this target state. Even though here we say Q1 2026, we could say this requirement is one of other requirements realizing this target. Or we have the resources to implement all of it. This is a discussion at a later stage in the ADM method. We can even add a grouping of the entire thing. So this entire grouping, and this is target architecture. Feature 21, feature 001, 2026. If we have some ticketing system for the features or the architecture work package, send it to the back. And again, zoom in and zoom out, add the compositioning and relations, keep it clean, keep it organized so that you can reuse the elements later. All composition relationships. Remember that here you have your business elements. You can see all the business elements from the entire project. If we change the name of one of the elements here, it will be changed automatically in all of the views that we have. So this is also one of the things that you need to be aware of. The reusability of the ArchiMate standard. This is really valuable and it could save a lot of time if you are under time stress, and then you need to make small changes. Always refer to the elements here in the different layers. And finally, this is a realization of this feature. Here we go. We have a complete cycle with infrastructure physical layer, application or technology layer, application layer. We have business layer elements as well. We have the motivation layer, and we could even go further and add the strategy and the resources needed to implement this requirement. So to implement this requirement, we need human resources, we need manufacturing resources, manufacturing capability, we need customer facing resources, we need customer support, we need cloud resources. So you can even show the resources. You can have here capabilities. We need AI capability. We need manufacturing capability or manufacturing partner. We need, as we said in the first of the case study, that we are the manufacturers, we are the electronic enterprise, electronic manufacturing enterprise. We could say it the other way around. We need the software partner, software operations or cloud operations partner, cloud capabilities. You can see this is all associated with the requirement to realize the requirement, of course. The capabilities also realize the requirement. So this one requirement, just one requirement, but all of this target architecture resources and capabilities are needed to implement it. Make it orderly and make it quite organized. And here we go. We have one complete target architecture, a case study, a use case of a smart home modeled using ArchiMate specifications for architecture modeling, aligned with TOGAF architecture development method ADM, covering alignment between different phases, steps of the ADM and different architecture layers. Hope you find this video session useful, helped you through your career as enterprise architects and IT architects. See you in future sessions.